I just want to kind of walk through the review with you and help you to make sure you understand what's asking, how to prepare, etc. So this is just the review that you have posted in Canvas. It says the test will consist of 15 problems. You'll have 60 minutes to complete the exam. It will be 15 problems. There will be no omits on the exam. You will have 60 minutes, and in the last 5 minutes, your timer will turn red to signify to let you know that you're about to run out of time. It will time out after that. If you work a problem on your calculator or show no work and just place an answer, there will be no full credit given for it. A lot of the things that you'll do in this course is not just a matter of getting the answer to be 4, but it's a matter of proving and facts that go with it. You will not need really any calculator. I'm going to go in and fix that. The on-screen calculator is the only calculator that you may use. There will be no formula or notes allowed. All you will need is blank paper before you begin the exam. Scratch paper will be graded. I do like to see every step along the way. Again, a lot of the things in this unit are proving on how you got to the answer, not necessarily just getting to an answer. Notation will be graded on top of that, so please make sure that each of your problems are written out correctly, as though I were writing them out through the lectures. I will grade the entire exam, so you made an 82. Any notation that is missing or overmarked will be a -1 off top of the overall grade. So I want everything to be very precise. When you're executing limits, you write limit until you evaluate them, and then you no longer write limit. You'll see that in a couple of the examples now. So what I want to do is just kind of go through some examples of what to expect. All this should not be a surprise. If you've been working through the homeworks and feel confident in that, then you'll feel confident in the exam. First one says evaluate a one-sided limit given a graph. This is one you'll see it a lot in the beginning sections where you had some kind of piecewise function going on and you had to find some limits as they were approaching. And so remember, the big idea with limits is you want to remember as you're working your limits, it is this idea of what is it approaching, not necessarily where it evaluates at. They could be the same, but again, think approaching. And so if we are looking at, say this is -4, if we were looking at what is the limit as x approaches -4 of this function, if we're coming from the left, that means we're going to follow this curve till we get closer and closer and closer to that value of -4. And we'll say that that value is at about +2. Remember, the tiny little notation up in the right-hand corner tells you the direction in which it's coming from. And again, I would just walk through, maybe review the lecture videos. That would be a good recap, or go back in and try those homework assignments again. If it said, what is it as the limit? We'll just hone in on this -4 here, -4 coming from the right of this function. Then again, you just follow this and you say, okay, what does it look like it's approaching? And we can see that's a value of 0. So if they have left hand, no big deal. If they ask right hand, no big deal. But if they ask it just conclusively, this actually does not exist because these are not the same. Now, in relation to evaluate a one-sided limit given a graph, you can see a lot of this. I'm pretty sure like the graph is kind of red. And again, you want to follow the idea of what it's approaching. Now, in the next bullet, it lists all these different areas that we can take a limit. So if limits, we want to take that idea of what it's approaching. The first aspect that you want to do is you always want to substitute in for it and see if you can evaluate. If you can substitute and evaluate, just roll with that, and you'll have one of those. If you find that every time you substitute in, it says D and E, that means you need to try something else. And so that's where these rest of these bulleted lists come in. You could factor first, maybe factor that quadratic out, see what things cancel, and then follow through from there. Quickly, I can kind of do an example. Say I have the limit as x approaches 1 of x minus 1, and I'm going to go ahead and, for time's sake, have one that's factored in the top. If it's already factored out, I could cancel those factors. Notice my notation, I have not dropped the word limit because I haven't taken it yet, and so I'm only the limit as x approaches 3, and then I can evaluate from there and just get the limit to be 4. But always try to substitute in first. It may have worked out. In this case, we got division by 0. Now, so you could try and see if it factors or cancels. Some of those on your trig situations, they did work out, but you need to use your knowledge of your unit circle. No unit circles or formulas, etc., will be given. So just remember there was 2 trig limits that we made good use of. There was this one here that had sine x over x, and that was equal to 1. And the limit as x approaches 0 of 1 minus cosine x all over x, and that was equal to 0. Now these two are proven by the squeeze theorem. They're two facts that you need to know, and they'll make your life a little bit better. Now again, we've talked about how your scratch work is a lot of times proving what's going on. There was one example in the lecture as well as the homework that had something like this. It's important to note that when you're using this known limit, these two pieces had to be the same. So since my two pieces were not the same, then what I would have to do is multiply by a fancy one. That fancy one would be like a 5 over 5. And in doing that, that would give me the limit as x approaches 0 of sine 5x over 5x. And by your properties of limit, this 5 right here could just come out front, and that's why you have it see it placed here. So that this piece, I could use that known fact, and I get 5 times that known fact is just 1 to give me 5. Now, in relation to scratch work, all of these steps would need to be shown. This is one of those cases where, yes, after repetition, you're like, oh, I just know it's going to be 5. But in the case of showing your work, it's a matter of, look, here's the proof or the facts of why it could be 5. So you want to kind of show those steps in between. I'll be looking for 3 things. The fancy one of the 5 over 5, the fact that you can apply your limit properties and move the 5 out front, implement what that limit is equal to, and then, of course, the final answer. Just getting the final answer of 5 is not your whole points. These problems are going to range from 6 to 7 points apiece. And so, okay, you wrote 5, but you had nothing else written down. That's not going to give you full credit. So that's something to remember with your trig functions. I'm going to come back up here to my limits. We have the possibility of division for the limit. Remember from the notes, that's when we looked at synthetic. You want to use that case when you have powers or degree of polynomials higher than the degree of the polynomial in the numerator. Use your synthetic division, and in working that, you would write the problem, do your synthetic off to the side, and then start back writing your problems to show what that limit would be working with now. Also, you want to remember your greatest integer function. There was some information not only in the lecture but in the homework on how those functions look on a graph, how they work and evaluate wise. Let's see, the piecewise function, we talked about that here when we were looking at just this information of this graph. So that's one situation you might be looking at. The other situation may occur here where it says f of x is equal to, and they give you 2 different functions. And again, it gives you the conditions. Now, if we're looking at what is the limit as x approaches 0, it's not going to hold your hand and walk you through each of those problems. You're going to have to go, you know what? 0 is where it changes from each of these. So I know I need to take this and not only do the limit from the left, but I also need to do the limit from the right. And then based off the answers I get here, I could conclude what the limit of this function is. So it may not directly say, what is the left limit? What is the right limit? Now get your limit. It may just mean you need to know to check the left and right. Make sure that they're the same before you can state the generic limit of what x is as it approaches 0. And remember, when you're doing that, you're going to start with your conditions over here first, and then use the individual equation that goes with it. So for example, on this one, as the limit as x approaches 0 from the left, that means I would be using x plus 10. So it would give me 0 plus 10 to be 10. Coming from the right, that means I would have 0 plus 4 times 0, which gives me 0. And look, these are not the same. Therefore, my limit does not exist. But this is the proof of how I got that answer. Again, it's not a matter of just writing D and E on any of your problems. So I just want to kind of go through and hit some high points to kind of help explain that second bullet. The next part says, given a graph, use the definition of continuity. So let's review continuity. When you're talking about the continuity of a function, there's 2 different ways you're going to see it. There's, first of all, just its definition. 1, f of a has to exist. Step 2, the limit as x approaches a of f of x exists. And then step 3, f of a is equal to the limit as x approaches a of f of x. So here's how you're going to work through this process. You saw some questions like this on the homework where you have to go, which one of these didn't work? This does work in a consecutive movement from the first to the last. So if at first f of a doesn't exist, you're done. It's not continuous if you can't prove part A. Number two, if the limit doesn't exist, again, you're done. You don't have to go to step 3. Now, step 3 seems kind of trivial because you might just looking at it, but remember, when you're showing your work for this exam, it's proof of your answer, not just some random numbers written. So if you're trying to prove that something's continuous, you would have to show 1, 2, 3, and then say, therefore, because of the above, this function is continuous at this value. So again, approach these type of situations as you are proving why this is continuous, not just randomly getting things. F of A exists, say you get 4. The limit exists, you get 4. Number 3, you need to walk through that step and say, well, since f of a is 4 and the limit is exponential a of fx equals 4, therefore this function is continuous at, and state all those problems. It will be given in a sense of what you've seen on the homework, but it'll also be given in a sense of what you saw in the lecture when we had to go through and prove all 3 steps in an essay type situation. Again, scratch work's going to be given. I'm going to be looking for all these things. Just saying it's continuous or discontinuous may be 1 point. The other 6 points would come from these facts or proof of how it's continuous, and that's walking through those steps. And then the last part was how we brought this whole unit together, just the slope of a tangent. Is taking that secant function and taking the limit of it. Your best bet for studying for this is to review the lecture videos, work through those homework problems again, and then also be aware of your notation. Your scratch work should not look like random things written down as though you grabbed a piece of paper and just chicken scratched through it. It should look like an answer key for the exam, very precise, notation, everything in play. It will be graded, so the exams will take longer to be graded. If you need additional assistance, please reach out. I am always here to help.